Hi everybody, hope you guys are doing well. We're gonna start section 5.4 out of the pre-calc book here today, and those topics include trig functions of real numbers. We're gonna talk about domain and range, periodic functions, what else? Even odd functions, and we're also hopefully going to get to some application questions. We might have 2 videos to get that done. So my first slide here, definitions of the trig functions in terms of the unit circle. It says if t is a real number, meaning t radians, and point p, x, y is a point on the unit circle that corresponds to t, then we know that all of these things are true. So what this is saying is, as you've been working with your unit circles, you know that as you travel around to the different points, by now we know that the x coordinate is equal to the cosine value. We know that the y value is equal to the sine value. That angle in radians, which would be angle t. So here they are. Sine is equal to y, cosine is equal to x. Tangent, remember, is the same as sine over cosine. So we can say that that's the same as y over x. We do now have to add these restrictions. Those restrictions come into play whenever we're doing division. We can see them in the cosecant, secant, cotangent, and tangent. And that is because the denominator cannot equal 0. Okay, so tangent of t is y divided by x, but not when x is equal to 0, then it would be undefined. Cosecant, this is the reciprocal function of the sine, so 1 divided by y, but again, it's undefined whenever y is equal to 0. Our secant is the reciprocal function of cosine, so 1 divided by x, but again, undefined when x is equal to 0. And then our cotangent is x divided by y. That's the reciprocal of tangent, but remember, you can also think of that as cosine divided by sine. And that one is also undefined when this time the y value or the sine value is equal to 0. See how that flip-flops there, which makes sense. So let's do an example that goes along with those ideas. Instructions say a point P is on the unit circle corresponding to an angle. Find the values of the 6 trig functions at that angle. So I'm given a point, x and y, and I'm going to use those ideas from the last page. My sine of, maybe it's t, maybe it's theta, should be equal to the y value, so I know that that's -√3 over 2. My cosine value is going to be equal to the x value, so I know that that's +1/2. If you think about that, now that we have x and y value or sine and cosine value information, we can now identify what quadrant this angle's in. It's where cosine or x's are positive. So that narrows it down to quadrant 1 and quadrant 4. But it's where our y values or our sine values are negative. So this angle must be in quadrant 4. Okay, and then I'm going to do tangent. Tangent is equal to sine over cosine, or it's going to be y over x. So that would be -√3 over 2 divided by 1/2. Multiplying by the reciprocal, or you can also cancel the denominators right away this way. We're going to come up with -√3. So there's our first 3 trig functions. Now we're going to go through and do the reciprocals. S goes with C, C goes with S, so cosecant is the reciprocal of sine. I would do the reciprocal, so 2 over -√3, and I'll need to rationalize that. So that will become -2√3 over 3, final answer when I do that. The reciprocal of cosine is secant. The reciprocal of 1/2 is just 2. And then lastly, cotangent. It will be the reciprocal of -√3. I'll need to rationalize that, so -√3 over 3. Okay. We're not asked many direct questions about domain and range, but I do want to mention this now. This is really going to come into play when we start doing our graphing of sine and cosine functions in section 5.5. So domain and range, if we again refer back to these functions as sine of t is equal to a y value, cosine of angle t is equal to an x value. Let's first talk about domain. Those would be input values into these functions. What could t possibly be? Well, those are going to be angle measures. Those are radians. What kind of things are we allowed to input? Well, there's actually no restriction. I can start at 0. I can go around the unit circle. Here's 2 pi or about 6.28 radians, but I could keep going around and around and around, etc. And remember also that we can go in the other direction. Here's 0. If I go this way, that's negative pi radians or negative 3.14, etc. And I can keep going. So I can have things increasing into the positive section forever and also into negative. So for that reason, our domain is all real numbers. For both actually sine and cosine, we can say our negative infinity to infinity using our interval notation. So now let's talk about what kind of answers we get. Let me get rid of this here. Okay. What kind of answers do we get? What kind of output values do we get for x? Well, let's just go around the unit circle. Here my x value, or remember that's like my cosine value, is 1. I'll come back for sine later. Here at the top corner of the unit circle, obviously I have a lot of values in between here, but I'm going to get to my extremes here at the top. When I get to the top, this value for cosine is 0. Keep on going, have a lot of values in between. When I get to this section, my cosine value is -1. And I'll keep on going. Here's another spot where my cosine is equal to 0. And we're going to finish back at 1. So if you look at the span of values that we have just covered, we have covered numbers from -1 to 1, including both of those. That is the range for cosine. Now let's do that same idea for sine. I'm going to use that same drawing. Sine values are y values. My y value at the 0 radians, or you could think 2 pi radians, is 0. Up at the top corner of the unit circle, sine value is +1. Here it's 0 again, here it's -1. So again, they happen in different spots, but we're still going to get that same range or potential span of output values there. So a little summary there for you. I'm going to hold off on tangent. We will talk about that later, but I don't want to get there quite yet. We're going to get a handle on sine and cosine first. And again, no direct questions covered covering this in section 5.4, but it is helping us prepare for section 5.5. Okay, this next slide, I do not want you to write any of this. I just want you to look at it. And I wanted to do this slide to refresh your memory on something that we talked about in term A of this course. Part of what we talked about when we did functions was talking about whether they were even, odd, or potentially neither. So I want to refresh your memory about what that means. If a function is even, we say that if you were to input the opposite value, you actually end up with the same output value. Probably our most simple example of that is a quadratic function. That is centered at the origin, that's key. And that's because if I input +1, I get an output of +1. If I input -1, I also get an output of +1. When we have an even function, just like this, we say that this thing has axis symmetry. And hopefully that's refreshing your memory there. That thing has axis symmetry. It's reflected over the y-axis when you look at its image. An odd function, on the other hand, if you input the opposite, you get the opposite output. So the example in the picture there is a cubic function. We say that these things have origin symmetry. Another example would be y equals x. There's a line with a slope of 1 and an intercept at 0. Those things have origin symmetry. When we plug in the opposite number for the input value, we get the opposite value for the output. There was, of course, our neither functions. I'm not going to spend time talking about that. That means if it's not either of these criteria, but that's really not going to come into play with our trig function, so I'm not going to spend time now talking about that. So let's see. We're going to determine whether our 6 trig functions are even or odd, and this can be a shortcut for you later on when you're comparing values. So I just want to start with an example. Cosine of pi over 6, that's here. So again, maybe you have this memorized by now. I've been seeing your unit circle submission. Some of you are getting pretty speedy. That cosine value, remember, is the x value. That's referencing the long leg of that 30, 60, 90 triangle. That's how I know that that thing is root 3 over 2 for cosine. Okay, so now to see if this thing is even or odd, what we're going to do is change to the opposite value of the input, negative pi over 6. I'll change colors too. That means we would be measuring clockwise. And again, I'm referencing that x value. And that x value is still positive root 3 over 2. So what we have proven there is that cosine is even. When we've done the opposite input, we still get that same output that we would have for the positive input. So I'm going to use that same spot on the unit circle, pi over 6 and negative pi over 6, and this time we're going to do the sign values of those. The sign value here would be positive 1/2, and the sign value here would be negative 1/2. And what that means is that sign is odd. Okay. So now think about finding tangent. Remember that tangent is the sine divided by the cosine. If I divide this y value by this x value, I'm going to get a positive something. If I were to divide this y value by this x value, I'm going to get a negative root 3. Root 3 over 3, excuse me. This is negative. Tangent at this point is negative root 3 over 3. Tangent here is positive root 3 over 3. So that says that tangent is also odd. Secant is the reciprocal of cosine. So if I were to do that same experiment with the pi over 6s, we're going to get the same value. That means that that is even. Cosecant is the reciprocal of sine. That's going to be odd. Cotangent, the reciprocal of tangent, also odd. Doing the reciprocal is not going to change the situation there. So you'll notice that the only two that are even are cosine and secant. And a little memory trick that Mrs. Kendrow taught me back in the day was to say that coseven, that cosine and its reciprocal function, are the only functions that are even, and that can be a big shortcut for you. I think I'll end this video with one final example. This does reference, it's using our knowledge of even and odd functions here. The instructions are going to give you several things like this. They're going to say sine of t equals something, cosine of t equals probably b, and tangent equals c, or something like that. And they're asking us to write this new expression in terms of a. And they're asking us to do that using our knowledge of even and odd functions. I know that because I look at this input value and they're asking us about an opposite input. So I think it might be helpful first to determine what we think that sine of negative t is equal to. We just decided that our sine functions are odd. That means when I put in an opposite, I'm going to get an opposite output. So sine of t is equal to positive a. Sine of negative t, opposite input, is equal to negative a. So let's go ahead and replace that. 5 times, I can replace that value with negative a minus the sine of t. Oh, that's original positive a. That's negative 5a minus a. And I can combine those like terms to come up with negative 6a. Okay, so I think that's going to get us through probably more than the first half of 5.4, and I'll wrap it up in a second video here shortly.